Let's take a look at this quadratic function which is given to us in standard form. And let's recall that in standard form, a quadratic function is given as a times x minus h squared plus k. And I should say the square of x minus h plus k. And the a is the same a that we're used to dealing with. H is the first coordinate of the vertex, and k is the second coordinate of the vertex. So when we are asked what are the coordinates of the vertex, and our parabola has been given to us in this standard form, there's actually no work for us to do to get the coordinates of the vertex. It's just a matter of being able to interpret the standard form. The first coordinate of the vertex is the number that's being subtracted from x in the quantity that's being squared. So 4 is being subtracted from x. So that's the first coordinate of the vertex. K, the second coordinate of the vertex, is the number that's being added to the quantity that's being squared. So in this case, that's 2. So my vertex is 4, 2. Because A is negative 2, which is less than 0. So remember, A is the number. When my parabola or quadratic function is in standard form, A is the number being multiplied times the quantity squared. When that number is negative, which is to say it's less than 0, to be negative means you're less than 0, means that the parabola opens downward. So whenever A is a negative value, the parabola always opens downward. The equation of the axis of symmetry is always x equal to whatever our h value is. And in this case, h is 4. So the axis of symmetry is the equation x equal to 4. When we go to find the x-intercepts, if there are any, we are setting the function minus 2 times the square of x minus 4 plus 2 equal to 0. So we will isolate what we're squaring, and we're going to do that by subtracting 2. So whenever you're finding x-intercepts of a quadratic function given in standard form, the square root property is going to be the best property to use. So I subtracted 2 from both sides, and now I'm going to divide both sides of the equation by negative 2. So I have the square of x minus 4 is equal to 1. Now I'm going to apply square root property. So x minus 4 is plus or minus the square root of 1, which is plus or minus 1. And now I'm going to solve for x by adding 4 to both sides. So x is 4 plus or minus 1. So that means that x is either 4 minus 1, which is 3, or 4 plus 1, which is 5. So my x-intercepts then are x equal to 3, 5. If I'm entering this into my math lab, that's the way it would be looking. It says type an exact answer using radicals as needed. Use a comma to separate answers as needed. Find the y-intercept. So the y-intercept is the function evaluated when x is 0. So I go into the function and in place of x, I put a 0. So this is negative 2 times the square of negative 4, which is 16, plus 2. So negative 32 plus 2 is negative 30. So my y-intercept is actually a negative 30. All right. And let's take a minute and let's incorporate this information into the graph. Now remember, the vertex was the point 4, 2. So there's the point 4, 2. That's my vertex. The x-intercepts were 3 and 5. The y-intercept was negative 30, so that means I'm not even going to touch, because my graph only goes from negative 10 to 10, I'm not even going to touch the graph. The graph's y-axis is what I really meant to say. So remember, the function is f of x equals negative 2 times x, the square of x minus 4, plus 2. Okay, so if x is 2, let's just get that point in here. If x is 2, I have negative 2 times the square of 2 minus 4 plus 2. So negative 2, the square of times the square of negative 2, which is 4, plus 2. So this is negative 8 plus 2, which is negative 6. So when x is negative 2, I'm at negative 6. And that means, since that's 2 units from the vertex, then if to the left of the vertex, then there's going to be a mirror image of that 2 units right of the vertex. And let's see what f of 1 is. So that's negative 2 times the square of negative 3 plus 2. So that's negative 18 plus 2, which is negative 16. And again, that means that I'm not even going to reach that point on this graph. So as I go down, I'm not going to touch. It's a little hard for me to draw straight on this electronic tablet. Alright, so that gives me just a nice approximation of what the graph would look like. So if you're doing this problem in my math lab, you are going to get these choices, and notice you could eliminate C and B without a whole lot of thought, because you know the parabola doesn't open upward. And then once you know the vertex is the point 42, you can correctly pick choice B. And then finally we want to give the domain and range. The domain of any parabola, any quadratic function, is always all the real numbers, which I give in interval notation as the interval from negative infinity to positive infinity. Now the range, since this opens downward, will be all y values below, so that's why I'm using the negative infinity, all y values below and including the highest y value, which was 2. So for a downward opening parabola, the range always goes from negative infinity to the k value of the vertex. So if the function opens downward, then the vertex will always have this form. The range will always have this form. It will go from negative infinity to k, and it includes k.